Hello everyone. In the previous video, we discussed the approach to the very popular and important problem binary search. Now, this problem is important. I highly recommend that you go watch the approach video before going on to the solution that I'm about to write in this video. That would really help you understand what I'm doing. Alright, so once you've done that, you will come here and I will start with the solution, which starts off with defining the initial search range. That is, our lower bound starts at index 0 and our upper bound starts at the very last index. Once the search bounds are in place, we have to keep on processing all the elements till all of them are processed. This condition takes care of that. How does it take care of that? The lower bound, which starts at the very beginning, that will simply always be less than the higher bound, right? So if it becomes greater than the higher bound at any point, that would mean that we've completed processing all the elements. So this is the condition we go with. In it, we have to define our midpoint index as we discussed in the previous video. That will be found in such a way: low plus high divided by 2. So when we have our midpoint, we discussed that there are certain conditions that we have to check with respect to the element at the midpoint, such as the element found at the midpoint of this array or our search range in particular, that should be equal to target. And if it is equal to target, it should not be equal to target. We will check if it is equal to it. If it does happen to be so, we will simply return its index. We have already found our target. We don't need to go any further. We will return the index of this midpoint. But if that is not the case, then we had two other options, right? Either our target will be found in the first half or in the second half of our array. So if our midpoint, if it is less than the target, that would mean that everything below the midpoint in this sorted array does not count. We don't need it. So we search in the second half, right? Target is in second half. Let's just write that down. So if the target is in the second half, we have to search starting from the element right after the midpoint till the very end of the array, right? That would mean the lower bound will come up to mid plus 1. And if the case is inversed, if our midpoint happens to be greater than the target, that would mean that the target is in the first half, because everything after the midpoint is irrelevant for us because the target is smaller, right? Target is in first half. So we reduce the search range to the element right before the midpoint. So the high variable becomes mid minus 1. Alright, so these are our conditions. But what if all the elements are processed, low becomes higher than the upper bound, and our element is still not found? In that case, we simply exit the loop whenever this condition does not satisfy, and we return minus 1. But I feel like this is still not the complete answer, even though it is basically what we discussed in the previous video. Why is that? But before that, I want to prove that it is the wrong answer. So we submitted, we see the basic test cases, and you can see that it's running for a very long time. It gives us time limit exceeded. So the reason why that is happening is because we are using JavaScript to write our solution. In another language where this division is integer division by default, that would not be the case. But in JavaScript, it will give us a floating point value as an output. So what we are going to do is we are simply going to convert it into an integer division. So math.floor can be used to achieve that. So we float this entire thing. So if we have, let's say 3 plus 4, it would give us 3.5 otherwise, and math.floor would make it 3. That is what we want. So if we try to run our basic cases again, that should pass now. And once we submit and check for all the test cases, we will see that this solution will be accepted with a very good runtime. It cannot be better than 0 ms. So in the next video, what we're going to do is we're going to solve a variation of this problem. It's going to be very interesting and it's going to enhance your knowledge like no other question. So stay tuned and follow for more.